Since the dawn of humanity, we have been on a quest to understand our origins. It wasn't until the 20th century, with the accumulation of knowledge in particle physics and astronomy, that a new theory was proposed, the Big Bang Theory. According to this theory, the universe began with a massive explosion about 13.8 billion years ago, from which all matter, space, and time originated. For a century now, the Big Bang Theory has stood the test of time and largely been accepted by the scientific community as a cornerstone of modern astrophysics. However, not everyone fully endorses the Big Bang Theory. In recent years, several scientific papers have challenged the idea, proposing that the Big Bang never occurred, causing a stir within the scientific community. Wet evidence leads some to believe that the Big Bang never happened. Join us as we explore the shaking foundations of the Big Bang Theory. Let's delve into the discovery and subsequent scrutiny of the Big Bang Theory, first proposed in 1927 by Georges Lemaitre, a Catholic priest and physicist. The theory posited that we live in an ever-expanding universe that was once smaller, hotter, and denser than it is today. He referred to the origin as the primeval atom, despite initial skepticism. Decades of cosmic observation have lent credibility to Lemaitre's idea. The Big Bang describes the universe at its inception, around 13.8 billion years ago, with all space, matter, and energy stemming from a singular explosive event. This doesn't imply a violent explosion, but rather a point at which the universe's matter, space, and time began. Imagine all matter and energy of the universe once condensed into an infinitely small space, even smaller than a punctuation mark. This incredibly hot and dense state began to expand rapidly. This hot, dense phase produced light elements through nuclear fusion. Following the inflationary period, the universe cooled enough for energy to convey various subatomic particles, including protons, neutrons, and electrons. However, it took thousands of years for electrically neutral atoms to form, with hydrogen, helium, and a trace of lithium being the first elements. Giant clouds containing these primordial elements eventually collapsed under gravity to form the fullest stars and galaxies. Heavier elements were synthesized within stars during supernovae. Since its first proposal, the Big Bang Theory has become a robust pillar of modern astrophysics, underpinning thousands of scientific papers and textbooks. Its acceptance is due to its comprehensive explanations of various cosmic phenomena, including the abundance of light elements, the cosmic microwave background radiation, the universe's expansion. However, not all scientists accept the Big Bang Theory. Plasma physicist and astronomer Eric Lehner has been a vocal critic for over 30 years. In 1919, he published The Big Bang Never Happened, supporting plasma cosmology over the Big Bang Theory. Plasma cosmology suggests that cosmic phenomena can be explained by well-understood physical reactions observed in laboratories. Despite Lehner's controversial stance, in May 2004, an open letter signed by 35 astronomers and physicists was published in New Scientist, asserting that the Big Bang Theory has not been proven and contradicts astronomical evidence since then. Over 200 astronomers and physicists have added their signatures, challenging the Big Bang consensus. Lehner continues to publish articles disputing the Big Bang, including a 20 interview with Asian Times titled The Big Bang Never Happened, presenting evidence of contradictions with the theory. He argues that the universe contains objects older than the supposed time of the Big Bang, that predictions about the distribution of light elements are wrong, and that despite predictions, dark matter remains undetected. Recent observations by the James Webb Space Telescope have added to the debate, discovering vast galaxies soon after the supposed Big Bang. These findings, contrasting with Big Bang predictions of only young galaxies existing early on, are prompting calls for a conceptual revolution in cosmology. While discussions continue, it's premature to conclude that the Big Bang never happened. With new evidence and observations, we must carefully reevaluate our understanding of the universe's origins before reaching final conclusions. Science requires patience, and our study of the cosmos is just a blink in the universe's timeline. What are your thoughts on this topic? Share your views in the comments below. Since the inception of our species, humans have relentlessly sought to understand our beginnings. The 20th century marked a pivotal point with the advent of the Big Bang Theory, positing the cosmos originated from an immense explosion approximately 13.8 billion years ago, laying the foundation for all matter, space, and time. This theory has been a central tenet of astrophysics for a century, yet not all scholars are convinced. A number of dissenting papers have emerged, suggesting the Big Bang never happened, which shakes the scientific consensus. This contention arises from several contradictions between the Big Bang Theory and recent cosmic observations. Let's delve deep into this discourse. The Big Bang Theory, first proposed by Georges Lemaitre, has become the prevailing explanation for the universe's origins. Yet, it's faced with fresh challenges as new observations come to light. Critics like Eric Lerner, who argue against the Big Bang, have pointed out inconsistencies that cannot be ignored. One of the key pieces of evidence supporting the Big Bang is the cosmic microwave background and radiation. Consider the afterglow of the initial explosion. However, some researchers argue that the uniformity of the amp across the sky does not align with the expected variances of a singular explosive event. Furthermore, the theory predicts that gravity should have pulled galaxies together over time. Yet the observation of an accelerating universe expansion suggests the opposite is happening. The discovery of dark energy, the mysterious force that's driving this acceleration, has added another layer of complexity that the Big Bang Theory struggles to incorporate seamlessly. Moreover, the predicted abundance of light elements such as hydrogen and helium doesn't always match with what's observed in distant galaxies. Some galaxies appear to have a higher concentration of heavy elements, indicative of a more mature universe, even at great distances which we observe as they were shortly after the Big Bang. Another issue arises with the horizon problem. Parts of the universe that are too far apart to have exchanged light signals since the Big Bang exhibit remarkably similar temperatures. This suggests a faster-than-light method of information exchange, which the Big Bang Theory cannot account for without the inflation theory, which itself has not been directly proven. Even the concept of dark matter, proposed to explain the gravitational effects observed in galaxies and galaxy clusters, remains elusive. Despite intense research, no direct evidence of dark matter has been found, leading some scientists to question its existence and, by extension, the aspects of the Big Bang Theory that rely on it. The problems don't end there. The presence of large-scale structures in the universe, such as galaxy filaments and walls, challenge the time frame provided by the Big Bang Theory for structure formation. The complexity and size of these structures seem to require more time to form than the universe's age according to the Big Bang timeline. Additionally, the mystery of why the universe has more matter than antimatter, given that the Big Bang should have created equal amounts of both, remains unresolved. While the Big Bang Theory provides mechanisms like violation to explain this asymmetry, these processes are not fully understood and have not been observed to occur to the extent necessary to result in the observed matter imbalance. In light of these issues, some scientists propose alternative theories such as the cyclic model, which suggests the universe undergoes endless cycles of expansion and contraction. Others suggest that the universe could be infinite, both in space and time, rendering the Big Bang unnecessary. These alternative theories often posit that what we perceive as the Big Bang may be a phenomenon observable universe rather than the origin of space and time. For instance, some models suggest that what we observe as the Big Bang could be the result of the collision between our universe and another in a higher dimensional space. However, despite these challenges, the Big Bang Theory remains the most widely accepted model for the universe's origin, supported by a wealth of evidence like the observed expansion of the universe and environment. It provides a coherent framework that aligns with Einstein's theory of general relativity and has been refined over time to incorporate new discoveries, such as dark energy, in the quest for understanding our cosmic origins. We must be open to new ideas and evidence. The scientific method demands that we constantly test and reevaluate our theories in light of new data. As technology advances and allows us to peer deeper into the cosmos, we may find more pieces of the puzzle. The study of the universe is a humbling reminder of our limited knowledge and the vastness of the cosmos. As we continue to explore and understand, we must remain agile in our thinking, ready to adapt our theories to reflect the true nature of the universe. It is this pursuit of knowledge that has propelled humanity forward, and it is this same pursuit that will continue to illuminate the shadows of our ignorance. In summary, the Big Bang Theory is not without its critics and controversies. The ongoing discourse in the scientific community reflects the dynamic nature of scientific inquiry. As we stand on the precipice of new astronomical discoveries, we may need to revise or even revolutionize our understanding of the universe's beginnings. Perhaps the Big Bang is not the singular event we once thought, but part of a more complex cosmic narrative. New observations, particularly from the James Webb Space Telescope, promise to shed light on the universe's youth. If we find that early galaxies were as developed as those we see today, it could suggest that the universe's maturation happened more quickly than the Big Bang Theory can account for, or that the universe is no temporal beginning as we understand it. Additionally, the enigma of quantum gravity remains unsolved. Quantum mechanics and general relativity, pillars of modern physics, were at odds on the smallest scales. This disharmony hints that our understanding of the universe's fabric is incomplete. The quantum theory of gravity might reveal a cosmos without a singular beginning, possibly suggesting a pre-Big Bang landscape or a multiverse, while Big Bang-like events or but local occurrences. The role of black holes, too, challenges our cosmic perspectives. These gravitational monstrosities, predicted by Einstein's equations, crush matter to a point where known laws of physics break down. The information paradox, which questions the fate of information falling into a black hole, could have profound implications for the Big Bang, as both scenarios involve extremes of gravity and density. Moreover, the Big Bang Theory does not fully explain the low entropy state of the early universe. Entropy measures disorder, and the second law of thermodynamics dictates that entropy should increase over time. However, the highly ordered state of the early universe begs the question of how such order arose, if not from a preceding state. Furthermore, the theory of cosmic inflation, proposed to resolve the horizon and flatness problems, has its own set of issues. Inflation posits a rapid expansion of spacetime immediately following the Big Bang, but what caused inflation to start and stop remains a mystery. Additionally, some argue that inflation leads to the multiverse hypothesis, where an infinite number of universes exist, each potentially with its own laws of physics. This concept stretches the limits of testability, the cornerstone of scientific theory. The concept of time itself becomes hazy when discussing the universe's origins. If time began with the Big Bang, what does it mean to discuss it before? Some physicists propose that time might be a major property that arose within our universe, rather than a fundamental aspect of it. The anthropic principle also plays into these discussions. This principle suggests that the universe must be compatible with conscious life that can observe it. Some use this principle to argue for a fine-tuned universe, possibly one of many, each with different parameters, and ours just happens to allow for life. As we consider these alternatives to the Big Bang Theory, we are reminded that science, the pursuit of this knowledge, is a testament to our insatiable curiosity and our never-ending quest to find our place in the cosmos. Science is not a collection of unassailable truths, but a process by which we refine our understanding of the universe. Whether the Big Bang Theory stands the test of time or is replaced by a new paradigm, the spirit of inquiry that drives us to explore these profound questions is the very essence of the scientific endeavor. As we stand at the edge of our current understanding, gazing into the abyss of the unknown, we are reminded that each question we answer leads to a dozen more, and so our journey of discovery continues. Infinite as the universe itself. Thank you for watching, and we'll see you in the next video. Goodbye for now.